You've been educated on multi-switching and multi-gang switching. We're going to talk about switching backwards. This is a bit of a tricky one because it requires some thinking and you're going to change cables for the first time. All right, so you've seen this project. Now we've got a cable here. We didn't have that before because before we energize a circuit from here, right? So every single time that we have done any kind of lighting circuit, we've brought constant power to the switch first, then switch power has gone to the light. Switching backwards means you're going to have to send constant power to the switch and have switch power coming back. Meaning, we energize, we bring constant power into the light box, then we have a cable going down to the switch that brings constant power, and it also, in the same cable, brings switched power back to the light. As you can see, there's only 2 wires in this cable, so this would have to be changed over to a 3-wire cable. The 3rd wire in this cable is red. So there's many reasons why you'll find this in the industry. Sometimes it's easier just to have constant power in the attic if there's no crawl space or you're doing a renovation, and you just need to drill a hole down through the top plate, get to the switch, and be done with it. You run a 3-wire because you still need a neutral in every box. The black's usually constant power, and I always choose the red as the switch power back up to the light. In controls, it's the same way. You're going to find in the field, especially when you get to motor controls in grade 11, that a lot of times the load, or the light in this scenario, has power and the control devices need to be fed constant power and switched power. So let's go to the whiteboard to make sure we know what's going on. Backwards. So this is going to be your introduction to 3-wire cable. So just to review, a 3-wire cable has black and white, the same that a 2-wire cable has, but we have to have a 3rd wire and it's red. So you're going to be using 3-wire quite a bit in a residential installation. We'll talk about the other scenarios in the future. But for now, we're going to be doing switching backwards. And all that means, switching backwards means we are switching toward our power source. So as you can tell in this project, we're going to be energizing the light first, and the switch will be energized later. And then we'll have to have the switch power travel all the way back. As you can see in our cable plan, we'll go from power source to light, from light to plug, from plug to switch. Again, it's actually super simple. We just, again, follow these 3 rules, these 3 steps, and you're going to be able to do this quite seamlessly. So let's do our neutrals first. We come off the neutral bar, and we come into our light. Now this gets a little bit convoluted again. We can't have 2 wires underneath the screw, as mentioned before. So now we have to actually pigtail our neutrals. We've done this a lot already, so you should know what's going on. We'll put a moret. We'll put a pigtail to the white or silver screw, and then we'll let the neutral carry on. Now in a plug, there are 2 neutral screws. So we can go to one and continue off the other. Or you can pigtail. It's actually your choice. Just for ease here, we're going to go to the white screw on the plug for our neutral, and we'll continue on from this screw to the light. So what do you do with a neutral in a light that has no load after it? There's nothing after the switch. So why do we need to run a neutral? Well, there's a couple of reasons. More and more we're seeing electronic switches and electronic dimmers. Those use components like resistors and capacitors and diodes, and those need neutrals to run. So as we get advanced along into a more electronic world, we're going to be needing neutrals at almost every switch. This is a new code rule introduced in 2021. So you're going to see a lot of the old way where they don't bring a neutral. We'll get into that in a later booklet. So for now, in this switch, this is not an electronic one. We're not going to work with those in their shop. So all we do with that, as you should do in the field, is just put a moret on there just to protect it from touching the edge of the box. Done. That's our neutrals. That is the completion of our neutrals. Now, it's our constant power. So, very simple, coming off the breaker, we go to the light box. And this is where a lot of mistakes are made. We naturally, when we bring a power wire into a light, we want to bring it to the light itself. This is the most common mistake in this book that I want to say, pay attention to this. You don't want constant power to the light because the light is always on. You cannot control that light. That's not what we're after here. So you're actually going to moret this constant power, and you're going to keep it going. Keep it going. So now we're going to go to this plug. Okay? The plug, we go to the gold screw. Again, we have to bring constant power to this switch. So we have to continue on this power. So you got two choices. Either you can come off the top screw because they are connected, or you can do the pigtail. Either way. But for now, we will go off the top screw. Go off the top screw, we go to the bottom screw on the switch, and that completes our constant power. All right? As you can see, we have one last step, and that is switched power. And that is the one that gets complicated as well. So, please note, we've got to get a wire from there all the way to here. And we can't skip over the plug. We have to use the cables provided in the cable plan. So, we have used black and white in this cable already, and we've used black and white in this cable. So, we have to use a third wire, and that wire is colored red. So what we'll do is we'll come into the plug box from the switch, and in this plug box, we don't want to be switching a plug on and off. So don't terminate switch power onto a plug unless it's a switched plug, but don't worry about switch plugs, that's in a later booklet. So for now, we're coming into the plug box, and we're going to moret it. We're going to continue on this red wire because we've also used the black and white in this cable. So now we're going to continue on that red wire all the way through to the light. Terminating on the gold screw. That's it. That's switch power, and that's the entire circuit right there. That's all you have to do. So you notice we have a 2-wire cable, a 3-wire cable, and a 3-wire cable. Okay? So, in your booklets, try to draw 4A and 4B. Once you do, we'll review it to make sure that you've got their concept down pat, and then we're going to go wire it in the shop.